For today's lab, you're going to be determining the empirical formula of some compound of copper and chlorine. However, we're adding a twist to it. So you know there's two possible compounds of copper and chlorine. We call them copper chlorides. But this is what we call a hydrated copper chloride. So it's not just the copper chloride compound, there's also water attached to it. So what we're going to do today is first heat off the water, then separate the copper and the chlorine from each other so that you can get separate masses, and then it's your job to figure out an empirical formula. Okay, you will be given the mass of the empty crucible, and I'm going to put some of my compound into that. And you will be given the mass of the crucible with the compound in it. You can see that lovely greenish blue color. And now to drive the water off, we need to heat it, but we need to heat it gently enough that we don't drive off anything that isn't water. It is possible to separate this compound and drive off chlorine if we are too aggressive. As we drive the water off, you should be able to note a change in the color of the substance that tells you it's working correctly. Okay, you can see the change in color occurring. So when this has gone completely brown and that greenish color is gone, then we will let it cool for a minute and we'll take it on to the next step. You'll get a mass at that point. Okay, so now we have a completely dehydrated sample. In your data, you will have the mass of that dehydrated sample with the crucible. And what we're going to do now is work on separating the copper and the chlorine. So I'm going to take this sample and I'm going to pour it into a beaker. And I'm actually going to rehydrate the sample. So I'm going to add more water to it. And you can see it go back to that beautiful green color. And now, to get the compound to separate, we're going to do a replacement reaction using aluminum. So I'm going to coil up the aluminum, leave myself a little handle so I can come back and get it the next day, and I will hang that aluminum inside the beaker. And now we wait.